So hey everyone, I'm Raghav and in this video we will talk about Leetcode Contest 385. So this is the first problem of the contest. Count prefix and suffix pairs 1. The problem says that we have been given a zero indexed string array named as words, and we define a boolean function is prefix and suffix that takes two strings, string 1 and string 2, and it will return true if the first string is both prefix and suffix of string 2. Otherwise, it will return false. And here is an example. If the first string is ABA and the second string is ABABA, then in that case, the first string, that is ABA, is coming up as the prefix. See, it is coming as the prefix or in the second string, and as well as it is coming as the suffix in the second string. So in that case, this thing will return true. But if you talk about this has in these inputs where the first string is ABC and the second string is ABCD, it will return false because ABC is only coming as the prefix but not as the suffix. It has to come up as both prefix and suffix, only then it will return true. So the problem is quite straightforward, and what it says is we have to return an integer denoting the number of index pairs in this words given array ij such that I is less than j and is prefix and suffix of words ij is true. So that's what we have to do. Now the problem is quite straightforward. We have some array of strings and we have been told on what basis we will like, let's say if you have this as a string and this as a string, if you are talking about your I pointer being here and j pointer being here, you can easily determine whether it will return true or false by just checking if this string comes as a prefix and suffix in the string or not. Let us take an example. A, ABA, ABABA, and A. For this given input, you see this A is coming up as a prefix in this, and this. All these strings, right? You see, I for I equal to 0. There are three pairs. There are pairs where I is 0. 0, comma 1, this pair. 0, comma 2, that is this pair. And 0, comma 3, that is this pair. Where this A is coming as both the prefix and the suffix in the given string. And yeah, someone might have a doubt that what if there are two strings like AA? Will I consider this as the prefix and suffix both for the second string or not? So the answer is yes. Like in this case, you will consider this thing as like it is coming as a prefix as well and it is coming up as a suffix as well for the second string. So it will have the answer is 1. Right now for the current problem which we have been doing, like for the current example, it is having a pair with all of these strings. The second string is having a pair with this string, right? So the answer was initially 0. You saw that these two are forming a pair, the answer became 1. You saw these two are also forming a pair, you said answer is 2 now. You saw these three are also like these two are also forming the pair, so the answer becomes 3. For this A, is there any string where like the string can be the first parameter and the other string can become the second parameter? Like we have checked out all the strings which could have been there. You know, we have checked all the strings of the given array. So now we will check for the next string, that is there any string among these who can play as like this plays as the I index, and is there any string in this rest array where you can take this string as the second parameter? So yeah, it can form a pair with this because ABA is coming as a prefix and ABA is coming as a suffix as well. So the answer becomes 4. Can these two form a pair? Can these two form a pair? ABA is not really coming up as either a prefix or suffix in this given string, so the answer will be no, and the number of the answer will remain 4. Now we will check for this pair. Is it coming as a prefix or suffix for the second string or not? The answer is no. Obviously, it is not coming as either of them. So at last, we just got that the answer is 4. Now doing this thing is very simple. All you have to do is in the given array, you just have to check for each and every possible combination of I comma j. Just check for each and every possible combination of I and j. If this this thing gives you true, in that case increment the answer, otherwise don't. So what you have to do is check for every possible combination of I and j. If it passes, then the answer just increment answer, otherwise no. So let me show you my code. This is quite straightforward. What I did is for each and every possible combination of I and j, I'm going like this. Remember that j should be greater than I, like I should be less than j. So we are starting the loop of j from I plus 1. We are saying like this is just a condition. I know that if the length of the string I is greater than the length of the string j, then it is never possible for string I to come as a prefix or suffix for the string j, right? This is quite obvious. Yeah, if I'm having a string like a b a and the other string is a, I don't even have to try to find if this can come up as a prefix in this or not. I just know that if its length, the length of the string is greater than the length of the string, then it will never be there as a prefix or suffix. So I can just continue for this pair. I will just skip checking for this pair. Then I use two Boolean variables to keep track of whether the uh, first string is coming as a prefix and suffix or not. So initially I just initialize them as true. I stored their lengths, though you could have defined this thing here and then checked for n1 and n2 also. Okay, after that in the third loop, I am just going on for the length n1. I just want to iterate over the first string and check if the first, like if it has, let's say, n1 number of characters, if the string is having n1 number of characters, I have to check if the first n1 number of characters in the bigger string or in the second string are all of those characters equal to this characters of this string or not. If all of them are equal, in that case, this is a prefix in this string, otherwise no. And for checking if this thing is coming as a suffix or not, I just said, yeah, I will compare the last characters, the last second character, and so on till I just check out for this whole string. Each and every character should be matching with the last character of the characters from the last in the bigger string, है ना? So I'm comparing in this way for the bigger string, sorry, for checking suffix. Now what I did is I just ran one for loop because I had to run up a loop of n1 size only. If you want, you can run up one loop for checking prefixes and then one loop for checking suffixes. It's up to you. For checking prefix, it is very simple. Words I should not be, like, if it should be equal to words of jk. The kth, the character at kth index in the first string should be equal to the kth character of the second string. Otherwise, if this condition is not true, that is, if the characters are not equal, in that case, it is not coming as a prefix. So I will just set its prefix equal to false. Similarly, for suffix, I am comparing the like kth character from the back, and here also kth character from the back. And if both of them are not equal, in that case, the first string is not coming as a suffix, and I will just set it false. I hope that this thing is clear. Just in case if you are not really comfortable with suffix part, probably you need to spend some more time by yourself. I believe that it is now doable. At the very least, you should be able to, like now you should be able to understand this thing once you put up some efforts by yourself. And in case if the first string is coming as both prefix and suffix, then just increment the answer. And that's it for this problem. Let's move on to the second problem. In the second problem, it says that we have been given two arrays with positive integers arr1 and arr2. A prefix of a positive integer is an integer formed by one or more of its digit starting from its leftmost digit. Probably everyone already knows what is a prefix. Like 1, 2, 3 is a prefix to the integer 1, 2, 3, 4, 5. है ना? It is just matching the first few characters, first few digits, while 2, 3, 4 is not. Here 2, 3, 4 is not the prefix because it is not starting from the leftmost place. And a common prefix of two integers a and b is an integer c, such that c is a prefix of both a and b. Like in the example, if this is your number a and this is your number b, in that case the correct like if you just consider 5, it is coming as a prefix in both of them, so it is a common prefix. Similarly, 5 6 is also a common prefix, it is also coming in both of them. Similarly, 565 is also a prefix because it is also coming in both of these strings. Similarly, 5655 is also a prefix in both of them, whereas 56553 or 56554 are not common prefixes because they are not coming as a prefix in both of them. So they have given an example that here 565 is a prefix, you know, 565 is a common prefix to both of them, and the examples like these, okay, uh, these numbers don't have any common prefix. See, the first characters are different itself. There is no common prefix. What we have to do is we have to find the length of the largest common prefix between all the pairs x comma y such that x belongs to arr1 and y belongs to arr2. So before coming up to this part, let's first of all see longest common prefix. By longest common prefix, they mean that the common prefix with the maximum length. Like in this case, there are four common prefixes: 5, 5, 6, 5, 5, 6, 5, 6, 5, and 5, 6, 5, 5. All of these are common prefixes in both of these strings. But the one with like the common prefix 5, 6, 5, 5 is the longest one because it has a length of 4. है ना? So this will be our answer here. In case if we had to find out the longest common prefix in between these two strings, these two numbers. But the problem is not really that simple. The problem says that you don't really have to find the common prefix in only between two numbers. Instead, you have to find the common prefix in all the pairs of uh, integers x comma y, where the first element belongs to one of the arrays and the other number belongs to other array. So in the case like this one, 1 2 3 4 4 4, you will have to consider all pairs like 1 4 1 4, this one, and okay, let me use the note here. Probably prefix and common prefix and longest common prefix thing is already clear, so I'm just starting on with the part like I'm explaining this part now. You are being given two arrays, maybe like 1 2 3. This is the first array and the second array is 4 4 4. So in these two arrays, you will have to find out the uh, longest common prefix of all the pairs x comma y where x belongs to arr1 and y belongs to arr2. Probably this would also be clear, but let me still do a dry run for you. There are 9 pairs. The first pair being 1 comma 4, this being connected to this. The second pair being 1 comma 4, again like this one being connected to the second 4, and 1 comma 4 like this one with pairing up with this one. After that you will have 2 comma 4, 2 comma 4 coming up 3 number of times. Then like 2 will also have pair with all of these numbers, then 3 will also have pair with all of these numbers. In this way you will have basically, if the first array is having n1 length and the second array is having n2 length, you will have n1 into n2 number of common pairs. Like you will have these many pairs where the first number belongs to first array and second number belongs to second array. You have to find the maximum value of the longest common prefixes of all of those numbers. है ना? You just have to do that thing. So if have they given, okay, they have not given a very good example, I guess. Let's take this example for now. If the first array is 1 10 100, and the second array is 1000, then in that case there are three pairs. A pair that is 1 comma 1000, another pair that is 10 comma 1000, another pair that is 100 comma 1000. So here um, the longest common prefix in this pair is 1. The second pair is having the longest common prefix as 2, the length of the longest common prefix, and the length of the longest common prefix in this third pair is 3. Like 100 and 100 are both common prefixes, like is a common prefix to both of them, so the length is 3. You have to return the maximum length of any of the common prefixes you found. Of all the common prefixes you found in all the pairs, you have to return the maximum length. That's it. So if you just say that I will go on with the brute force method, you will say, "Yeah, I will first of all form all the x comma y pairs. It will take you big O of n1 into big O of n2 time complexity for forming all the pairs. After that, you will check on for every pair what is the longest common prefix. Now, since the elements of the array are numbers up to length 10 raised to the power 8, so they would have at most 9 digits in case if the number is 10 raised to the power 8. है ना? There are at most 9 digits. So for finding out the longest common prefix of a number, it will be something done in complex time complexity. It will be done in complex time complexity. So your overall time complexity will come out to be big O of n1 into n2, which will actually not work here. Big O of n1 into n2 will not work because here n is as large as 5 into 10 raised to the power 4. So n square, like n1 and n2 are basically as large as this one. So n1 into n2, like n2 will be as large as 25 into 10 raised to the power 8, which is very huge. You can't really pass on a solution like this one. So um, we have to optimize it. We have to think of some better way. Now I will um suggest you to first of all try to think of what comes up to your mind. Maybe you can actually try to manipulate the problem a little bit for yourself. The given numbers you had, what are the prefixes in this one? It has only a single prefix 1. This had two prefixes 1 and 10. This had three prefixes 1, 10 and 100. है ना? You have to just find out the longest common prefix. First of all, I am finding out the prefixes 1, 10, 100 and 1000. Like the problem is in a way that out of all of these prefixes, if any one of them matches up with any one of these prefixes, then there must be a common prefix from like you basically don't care what element you choose, right? From this array, you don't really care which element you choose. You only care about a prefix. है ना? You only care about some common prefix in any of the strings of this array and any of the strings of this array. So what if I just find out all the prefixes from this array once? If I just figure out all the if I just figure out all the prefixes from the first array and let me write them out here. 1 1 1 10, or maybe you just write it as 1 1 10. And basically in any way you write 1 10. What am I doing? Yeah, let me write all the prefixes here. 1 1 10, 1 10 100, and the second array has 1 10 100 1000. In that case, now what I have to do is I just have to find out the longest, like consider them as a string, है ना? Or just if I say that the length of this number is 3, I just have to find out the longest number which is coming up in both these numbers, both of these arrays. just find out the longest common number which is coming in both these arrays. The problem became like this. Why did I try to think about splitting the prefixes in this way? Like, why did I try to figure, like, find all the prefixes from the numbers? The reason is I know that for any number, like the largest possible number is just 10 is the power 8, it will have only 9 prefixes. है ना? A number like 10 is the power 8 will have only 9 prefixes. So I know if the array length was n1, the creating an array with just the prefixes will have a length of at most 9 into n1. Similarly, for the second array, it will have a length of 9 into n2. But on doing this part, the problem has now become a lot simpler. You have been given two arrays. You have been given two arrays. Let us just consider that you have been given two arrays of strings, and you have to find out the longest common string in both of them. And this is a very simple thing. You can just store all of these strings or numbers, whatever you consider. Just store them, all of them in a set. You can maybe create a set of strings and uh, you can maybe just create a set of strings and push all of them here, and now for each and every number in the second array, just traverse to one by one. Now if you're checking for this, just check if this number is coming up in the string or not. Earlier, if you were just checking if this prefix is coming, or if this number is coming in this array or not, it would take big of n time. But for checking in a string, it will take only big of log n time. So it will be a lot better. So first of all, what you will do is you will have n1 numbers which you just put up one by one into a set of strings. So it will take you big of n1 into log n time, log n1 time. है ना? After that, for each and every number in this string, in this array, actually, like the array length is n2, so it is, sorry, 9 into, it is approximately n2 now. Like we can just ignore the constant for finding out the time complexity. So here the time complexity will be, you are having n2 elements, and every time you are just searching in the set, which will take log n1 time, because the set has n1 elements, so log n1 time. So this will be a time complexity, and this can easily pass. It is nothing but big of n1 plus n2 into log n1, and it will easily pass. So that's what I did. Let me show you my code. Uh, Here for in this first loop, I am going on like instead of creating these two arrays, really creating these two arrays, I just found all the prefixes, and like for creating this array, we'll have to first of all find out all the prefixes. So once you find out all the prefixes, instead of creating storing them inside a new array, I just directly stored them inside the set. And when I was just finding all the prefixes one by one, instead of storing them in an array and doing that stuff, I was just directly checking if it is coming up in the set or not. So in the first loop, I'm going on for every element, converting that element to a string. Just for easiness, you can, if you want, you can just go on with the number, but I feel that string converting it to string would be easy. After that, I'm going on like just adding one character from in the string from left to right to a string s. So a string s would be nothing but a prefix of the current number at every point of time, and I'm just inserting that prefix into a set of strings. After that, I'm just doing the exact same thing for the second array, except this part is different. Instead of like the earlier, I was just adding. Now instead of adding, I have been checking that hey, if this prefix is coming up in the set, in that case, just say your answer should have been the length of the longest common prefix, right? The length of the longest common prefix. So you will just say your answer equal to the maximum of answer and s dot length, and I'm just type converting it to int because the type it returns is not an integer by default. So if you don't write this int, then you will get some error from while using the max function. you can try this out. Once you get the error, you will it would be better for you, so that you will remember this thing forever. So that's what we can do. I'm just storing the length, the maximum of the current answer and the length of the string into answer, and then at last I'm returning the answer. So I hope that this problem is also clear. Now let us see the third problem. The third one is a bit more interesting than first and second. In fact, this is the most interesting problem. It is more interesting than the fourth one also, and probably simple also. The problem says that you are given a m into n zero indexed 2D matrix mat. For every cell, you can create numbers in the following way. Like for every cell, we will do this, like the things which we have been given, we will do this for every cell. For any cell, like if you talk about a cell, this one or this number, which is at the first row and first column, there can be at most eight paths from that cell, namely eight directions. Like from one, you can either go only to the right, only to the southeast, or only to the south, either to east, southeast, or south. You will not change your direction. Yeah. So we will select one of these eight paths and then append the digits in the path to the number being formed by traveling in this direction. So if you travel from 1 towards the right, then you will get 1 and 1 1, right? If you travel from this cell to the southeast, then you are having a 1 once you have reached only till this position, and once you go to the southeast position, you will have 1 9. For the case when you move towards the south from the cell, you will have 1, then 1 9, then 1 9 1. They have mentioned this thing in the third step, that the numbers generated at each step, for example, if the digits along the path were 191, then there will be numbers generated along the way as 119 and 191. We will consider the whole numbers. And there are uh, we have considered three paths, but there are five more paths. Maybe you can go towards the north side, northeast, northwest, or west or southwest. In all those cases, you will have only this one element, and there will be no other element apart from this one, because there is no cell in any of the other directions. We will return the most frequent prime number greater than 10 out of all the numbers created by traversing the matrix, or minus 1 if no such prime number exists. If there are multiple prime numbers, then uh, we will return the prime number with the highest frequency. Uh, and in case, sorry, if there are multiple prime numbers with the highest frequency, then we will return the largest one of them. And they have a note that it is invalid to change the direction during a move. So you cannot be like, I will go from 1 to 9 and then I will go from 9 to 1. You cannot go in this way. You, if you go to the southeast, then you will only go to southeast path. So let me explain this a bit. We have been given, we will be given a matrix. The problem generally says that we have a matrix with n rows and, sorry, m rows and n columns, but I generally prefer to keep n rows. Like I will denote the number of rows by n and the number of columns by m. So this thing would be different from the problem. Like problem says the number of rows and columns to be m and n. I'm denoting it in the other way. Okay. Now for any cell, like let's say you talk about this cell, or maybe let's talk about this cell. Then there are eight paths. Either you go towards this path only, or there, or there, or there, or there, or here, or here. Any one of these places, just go on in only one direction. If you go here, then you will keep moving towards that direction as long as there are cells in the way. So if the cells are something like 2 7 3, then you will get three numbers here. A number 2 when you went, like you're just here. When you went till this point, you will get 2 7. When you went till this direction, you got 2 7 3, right? Similarly, for other directions as well, you will get some numbers. Maybe let us say there was a 5 here, so you would have got a number as 2 and 2 5. Like in this, while going in this direction, you will get 2 and 2 5. and maybe in this direction if there is a 7, you will get 2 and 2 7, 2 and 2 7, uh, sorry, 2 and 2 7. And for the other 5 directions, like here, 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 and here, there are no other cells there, so you will get only 2 2 2 every time, just 2, and there is no more cells in the while going in that path. Now the problem says that find out this thing for each and every cell. So for every cell, find out this whole thing, this set of all the numbers. So find all numbers for all these cells, and among them, like once you would have got all the numbers, maybe if there were more cells like this, if you talk about the 7, it will give you 7 and 7 2, 7 and 7 5, and then 7 5, whatever number is there, if it is 1 7 5 1. Similarly 7 and 7 7, है ना? Something like this, you will get a lot of numbers. Among them, you have to return the most frequent prime number. You have to return the most frequent prime number. But what if there are multiple prime numbers with the most like the same frequency, the maximum frequency? In that case, if there is no most frequent element, but there are multiple most frequent elements, in that case just return the largest element, the largest one of the elements which are most frequent. So in case if, let us say, um, maybe let us say that for some given input you are getting 29 and you are getting 31 as the two prime numbers which are coming 3 number of times, then you will return this number because it is larger than this one and the frequency is same, right? So focusing on the frequency is the first part, and when you get a clash between elements with the same frequency, you will um, store the return the one with the maximum value. That's it. So let us look at the constraints. You can look up at the example also if you want completely, though I think that it should already be clear. Maybe you can look at this, that for all the numbers which are greater than 10 are being found in the okay, yeah, one more thing. We had this constraint that the number should be greater than 10. If the number was smaller than 10, in that case the problem would be quite messed up already. Like, I'm not really explaining why, but in case if the number was the number could have been less than 10 also, then most probably all the prime numbers, like every time the answer would be less than equal to less than 10. At least most of the times it would be less than 10. There might be some exceptions. Can there be exceptions? Huh. There can be exceptions, but most of the times the number would be less than 10 if this condition was not there. So just look out at this. This is doable for now. Like if you have understood the problem now, looking at the example test cases and understanding, try running it is simple. You should be able to do it. After that, uh, we had to look at the constraints, because we see that the problem actually involves doing up a lot of things which generally we would like to do with brute force, and you see that uh, the number of rows and columns are very less. The number of rows and columns are very less, and yeah, that's it. By the way, every cell will have only one digit, a single digit number that will be from 1 to 9. So we see that at the very max, what can happen is we will have a 6 cross 6 matrix. We will have a 6 cross 6 matrix at the maximum. So there will be only 36 cells at the maximum from where we have to find the paths. There are only 8 paths for any cell, है ना? So there are only 36 into 8 number of paths, and for every path the complexity would be, the time complexity would be equal to the minimum of, like not just minimum, but like if you're talking about a path from here to in this direction, then it would go as long as either you do reach the first first column or the first or the last row, है ना, something like that. So as long as you don't just reach at the end of the matrix in in any place like this, either one of these rows or sorry those columns or these rows, it will go only then at till that time. So the path would also be not so huge. The path would be less than, or like the length of the path would be definitely less than 6. So at the very maximum, for finding out all the paths, it is taking only this much complexity, right? It is taking only this much time complexity for finding out all the numbers in the paths. So what I can do is I can just store all of those inside an array. I can just store all the numbers I can generate from all the paths from all the cells, which would be calculated in this complexity. It is very simple. Like it is just some simple implementation based thing. You just have to do whatever the problem said, word to word directly. You will get some array, and from that array you will first of all have to find out the prime numbers greater than equal to 10, or like 10 is not a prime number, so it doesn't really matter if you call it as greater than 10 or greater than equal to 10. But let's keep it like the problem. So you will have to first of all find out all the prime numbers which are greater than 10, like frequency of all of those elements, frequency of all these prime numbers. Now if you found no prime number, if you found no prime number, then return -1. The problem said that if there is no such, like if no such prime number exists, then return -1. So if you didn't find any prime number here in this array which we have created from the numbers we got from the paths, then the answer would be -1. Otherwise, find the most frequent prime number, and in case of clash just keep the largest value. So like this, doing this thing at the end is not so hard. Probably would have done this thing a dozen of times, hundreds of times maybe. Yeah. The main task we have right now is first of all find out all the prime numbers and store their frequency. Storing frequency is also not so hard. We can just simply use a map. We can just simply use a map of integers to store the frequency. So all we have to do is just find out all of those numbers. Now this is something implementation based. Probably if you have done graphs, you would be very used to such kind of implementation. Like in graphs, we do such implementation a lot of times related to this kind of paths. Otherwise, it might take up some more time from your side. Like the implementation thing is something you will get better as more efforts you put in. So I'm just showing up my code the way I did implement it. I would suggest you to implement it by your own. Don't copy my implementation. This is something you have to do on your own only. Um, for the way I did implementation, I first of all created two arrays, dx and dy, in which I just stored some random numbers. Like the numbers might look random, but in reality, the numbers are not random. If you see dx and dy, the first element of dx and dy, it is representing a direction -1, 0. Like at whatever cell you are, go on the previous row in the same column. 1 comma 0 is suggesting that go into the next row with the same column. 0 comma minus 1 0 comma minus 1 represents go into the stay in the same row but the next column. Like this says the previous column, this says for the next column in the same row, this says previous row previous column, this says next row uh, and previous column. Basically I'm just representing all the 8 directions I could have with these two arrays. You would have seen this thing in graphs if you have done graphs, and in case if you have not done graphs, you can still understand it, but it will take some more efforts by your side. I'm going on for each and every element, each and every cell in the matrix, and for each and every cell, what we had to do is we just had 8 uh, paths. So I'm having 8 paths. I said that initially my coordinates are I comma j, with x comma y and x and y I'm representing the current coordinates of the cell. Initially they are x comma I comma j, and the number I have is mat ij. That like if I'm at this cell, I'm initially having a number 1. Now, when I will go to the next number, whenever I will go to the next number, what will I do? I will go on in the same path, like x plus equal to dxk and y plus equal to dyk is taking me forward in whatever direction I have. है ना? Whatever direction we are talking about right now, and depending upon the value of k, we will go into that direction. If any of these conditions is true, basically, if I have got out of the matrix, if one of my coordinates have got out of the range of the matrix, then just break the loop, because we have just got out of the matrix, it is not included in the path. Otherwise, your current number, like this number, if you remember, it was increasing in this way. Initially when you were at this place, it was 2. When you went to this 7, you were adding 7 at the back of 2, or you can say that you just said here 2 is now becoming 20 and you added 7, है ना? Now from 27, when you went to 273, you said that this 27 is actually becoming 270 and you are adding 3. Either call it like this, or maybe you just um, have a string and push back. You know, like do it, and in a way it is up to you. I prefer to say yeah, for making 2 7 and adding 3 at the back, like for making 2 7 become 273 on adding 3 at the back, I will multiply 27 by 10 and then add 3. So that's what I'm doing here. I'm multiplying the number by 10 and adding the new number in the matrix. In case if the number I've got so far, I got a 27 here. So if this number is a prime number, then please add it into the map that hey, prime number, this prime number existed one number of time, and like so on, just increment the count. After that, when I come to this number, I will just say yeah, hey, if I have got, like if this is a prime number, then increment its frequency. So instead of storing all of those numbers inside an array and then finding the frequencies, I am at the same time, like whenever I'm finding the number, instead of adding it to the array, I'm directly incrementing its frequency in the map. So I did create a map with names count, like cnt here. I will increment the frequency here, and after that, in case at the end, if the map is empty, it means that I did not have even a single prime number, so my answer will be -1. Otherwise, you are finding out the, like, let's say if you just had to find out the number with the maximum frequency, you could have said yeah, I'm iterating over the map. This auto kv is nothing but, you would have seen something like auto it, and you say int k equal to it dot first and v equal to it dot second. We generally write like this. And if you have a modern compiler, like Leetcode has a modern compiler, C++ compiler, then in that case you can actually use this syntax for destructuring that, like auto k will, here if you were writing it, it would have been a pair of integers. If you just write k comma v inside the brackets like this, then the first value of it would be stored inside k and the second will be stored inside v. So k is the prime number we have and v is the frequency of that number. I am saying that hey, I initialized my answer as answer equal to 0 and frequency is 0. If the frequency of the current prime number is greater than the frequency of the number which I would have stored inside answer, in that case, in like say that my answer is the current prime number and frequency is v. In this way, you can find out the number with the maximum frequency, but we have to find out the number with the maximum frequency, and among the numbers with the maximum frequency, we have to find out the largest number. So maybe you could just think here, for that I can actually have a case here. If the frequency of the current number is equal to the frequency, I will just say answer is equal to max of answer and k. You can write it like this, it will also work. Or the other thing you could have done is, since you already know that we have been using a map, like this is an ordered map. See, this is an ordered map. Only because of that we know key the number which will come later on, uh, like basically in the count, the keys would be stored in ascending order, in the ascending order. So the value of key will only increase. So if you include n is equal to here and remove this line, it will also work. If you feel it confusing, then just ignore, just write it like this. It is also fine. Okay, it is also fine if you write it like this. Though I would suggest to write like this, like spend some time understanding it. Maybe try to print the map a couple of times to see how the things are stored inside a map, and just you will realize this thing. And later on, we will just return this answer. That's it. So I hope that this problem is also clear. For finding whether a number is prime or not, I did create a function with name is prime. This is a very standard thing. Probably it is clear. And I already know that the number I will give is never gonna be less than equal to 1. So even if you ignore this line, it will work fine. But it's a good practice to write a good prime number. Like it's not necessary, but you if you want, you can keep this line as well. Okay. So let us see the fourth problem. Uh, what did I do? I hope I didn't mess up anything. Again, let's come back. Now what we have to do is, like all we have to do is just the first problem we had seen, if you remember the first problem we saw earlier, there the constraints were very, very small. This time, the only difference in that problem and in this problem is that the constraints are higher. I believe that I don't have to explain the problem again. Like if you're coming up to this problem, you have already solved the first problem. So we can just start on with what we should do for this problem. When you did the first problem, when we did the first problem, we saw, yeah, for every occurrence, I can just check it for each and every, sorry, for every string, let us say, let's just take the example, A, A, B, A, B, A, B, A. So what we had seen is for a string like this one, for an array of strings like this one, for this number, I was just going on to every string and I was just checking if it is coming up as a prefix in any one of them, and like as a suffix as well at the same time. If it is coming as a prefix or and suffix at the same time in any of the strings, whenever it comes, I will just increment my answer. That's what I was doing. Right. Now, in this problem, if we do it in the exact same way like we did earlier, the time complexity we had was very bad. We had something like big of n square time complexity, not actually n square, but for every number I was just going on to every string, so I was at the very least having big of n square, and there I was having a loop of equal to the size of the length of the string, basically big of n square into length of the number, length of the string, है ना, length of string of the word. So there the length of the array was very small and the length of the strings could have also been very small, so it was not really a problem for us. But here in this case, the constraints are quite high, the constraints are very large, so we can't really do it in that way. Right, we can't really do it in that way. Let us try to see something else. By the way, there is one more constraint. You see, the sum of lengths of words I does not exceed 5 into 10 raised to the power 5. Basically, the total number of characters, the sum of like for now I'm just calling it as sum cap, the sum of characters of the whole array would be, the number of characters in the whole array would be less than or equal to 10 raised to the power 5, like 5 into 10 raised to the power 5 actually, this much. So let's see if we can somehow use this information. At the very least, something which should be coming up to your mind is, you have to compare, since we have to compare this string with some prefix or suffix, है ना? We have to compare like this string with some prefix or suffix, something like that we have to do. So at the very least, you should be getting up some idea of maybe string hashing or some other string algorithm, string matching algorithm, है ना? I like string hashing, so I will only consider talk about string hashing for now. But you can think about some other string algorithms also if it could work. Uh, so that basically you should already get the intuition of string hashing. You have to do things in optimized way. So how will you check if this string is coming up as a prefix and suffix in the other string or not? What you can do is find the string hash for this whole string. Like probably if you have like first of all study about string hash. Once you've studied about string hashing, you would have like encountered something like a string hash. People generally create a string hash data structure, maybe with some other name, in which you pass on a string. Let's say I pass on this string, and now in login time I will be able to find out the hash of any of the substrings of the string as well. Like if I say here, please tell me the hash of this region of the string bab, it will give you some hash value. You would have studied about this part also, to find out the hash value of some substring of the given string also. Okay. So what you can do is, you can compare the hash value of this string with the hash value of the prefix of this length and the suffix of this length of the other string. Let us say, let us say you have a string hash structure object for this string and for this string. For creating that substring hash, it will take n log n time for this string and in this string. Okay. Once you're done with it, I believe it, like I think it can be done in big. Like I'm not really sure if this thing can be done in big of n also or not, but at the very least it can be done in big of n log n. So what you can do is, first of all, just create string hash for each and every string in the given array. And now if you want to check whether this string comes up as a prefix or suffix in this string or not, for doing this thing you don't really have to run up a for loop of this much size. Instead, you can just find the hash of the complete string. You can just ask that substring hash object which we have created for the string, and find the hash for the substring from 0 to, let's say, m minus 1, where m is the length of the string, or maybe let's say just 0 to 2. 0 to 2, you will just say, please tell me the string hash, the hash value of the substring of this string from 0 to 2, basically the whole string. And from the other string, you will say, please tell me the hash value of the prefix with length 3 and the suffix with length 3. Now, let us say the hash value you got for this current string is hash. The the hash value of the prefix is pre-hash, and the hash value of the suffix is suff hash. Like you already know, if this string is of length 3, then obviously if there is any prefix which is equal to this, it would be of length 3. Any prefix of length anything other than 3 can never be equal to this string, right? So you will only find out the hash value uh, of those strings, or those prefixes and suffixes. Now comparing this is very easy. You will just say here, does hash, like is hash should be equal to pre-hash, and hash should be equal to suff hash, right? That is what we have understood. So if we have been given two strings, like in the function we had actually is prefix and suffixes, I'm for now calling it as is prefixes and suffixes. I'm like just writing up this function in short form for now. And you have two strings s1 and s2, and you want to check if the string s1 is a prefix and suffix for s2 or not. then now the time complexity it will take is only gonna be equal to big O of login, you know, something like that. It won't really be dependent upon, it won't really be equal to big O of n1, where n1 is the length of the string. It won't be that much. So we have got one thing at least, that now have we sort of have um, n characters in the string, sorry, n strings in the array. And for checking, for comparing any two strings, we can do it in login. So now we have optimized our solution to big O of log square n, which is at least better than the previous one, which is at least better than the previous one, but it is still not so good, like it will still fail. So we have to think of some better way also. Now if you see, since the number of, like the sum of lengths of words I does not exceed this length, so um, like from this, you, I'm not really sure if you are able to directly understand this thing or not, but it means, it is giving us a hint that the total number of prefixes or suffixes, like just look at this, if there is a string with length n1 here, it will have exactly n1 prefixes and n1 suffixes. And if, let us say, there is a string with length n1 and this was n2, then it will have n2 prefixes, suffixes, it will have n1 number of prefixes and suffixes, the third will have n3 number of prefixes and suffixes, and so on. And you know that the sum of n1, n2, n3 and so on is less than equal to, like you know that n1 plus n2 plus n3 and so on is less than equal to 5 into 10 raised to the power 5, right? So we can actually conclude here the number of prefixes and suffixes, which is nothing but this much only, would also be less than equal to 5 into 10 raised to the power 5, right? And for every prefix and suffix, let us say a string is a b a b a, it is having 5 prefixes: a a b a b a a b a b a b a b a b a, है ना? So here you don't really have to store the complete prefixes. All you have to do is just store the hash value of this string, like some hash value, right? Which would be an integer. The hash value of AB, the hash value of ABA, these will be integers. So can I say that from the given array of strings I had, I can actually generate an array, of length less than this much. For now I will, let me call this thing as, like, let me just write this thing here simply. The length of the uh like I can just generate an array of length less than equal to 5 into 10 is the 5, basically a length equal to the string, the sum of all the characters, the number of characters in all the strings, or basically the sum of lengths of all the strings. I can create an array of that length where every integer would be denoting some prefix, would be denoting the prefix of some string, right? And now one more thing, if in a string, let us say a b a b a, maybe a b c a, let us say this thing, if you have a string like this one, a is coming up as both prefix and suffix. So yeah, this thing is coming as both prefix and suffix. But should I really store AB or ABC or ABCA inside this array I was talking about? Like, you might be able to relate what we are doing here from the second problem we did. In the second problem, it was a bit simpler, though it was very easy to explain. Here, developing intuition might be a bit hard. What we are basically trying to aim is, instead of storing the, like we know that there are only some limited number of prefixes and suffixes, and only when a prefix and suffix are equal, only when this thing is equal, it uh, can have some like it like just imagine if you have the first string s1 as this and this is your s2, then for a string s1 which is equal to a, this this string might have a prefix and suffix which is equal to the string s1 है ना? But for length 2, for length 3, for length 4 and so on, for those lengths it won't really be the case. There can be no such string for of length 2 such that it is equal to both prefix and suffix, right? There can be no such string which is equal to both prefix and suffix, because my prefix and suffix are not equal in themselves. But if I had something like ab, then in that case it is possible to have a prefix of length 2, that is ab, which would be equal to both prefixes and suffixes. So only when I have a prefix and suffix equal in my string, like for length 2 these two are equal, I will add this thing inside some set or a list or anywhere, which will tell, yeah, I don't really care in which string it is, but in one of the strings there is ab coming up as both prefix and suffix. Now if there is any string which is equal to ab, if there is any string which is actually completely equal to ab, then I will increment my answer. Probably we have done up a lot of things, and I did try my best to develop the intuition here. Maybe you might still have to spend some time on your own to think on how, like, why are we doing this thing, like on developing intuition. You might have to spend time by yourself also, but I think that we have got some solid hints and it should be doable now. So the thing is, in the given string I had, this string, like let's say this is my string s1, I want to find out how many strings are there in this whole array which are coming up after s1, such that their prefix and suffix both of them are equal to s1. That is what I wanted to find out. So for that what I said is, I will just say for all of these strings I will store their prefixes and suffixes inside some set or a map or some list or wherever you want to store. I will just store it somewhere. If I got something like A B A B A, I will say here in the string A B A B A and A are coming up as a prefix and suffix both. So I will store that, hey, uh, A is coming up as a prefix or suffix somewhere. Let's say if there was some other string A here, it will also have a coming up as a prefix and suffix both, so it will increment the value of a by 1. It will make a 2, and at some point of time when I reach to this string s1, which is actually just nothing but a, string a, you can just find out the number of times a came up as both prefix and suffix in any of the strings on the RHS inside the map you would have created, है ना? You can just create a map to keep track of the frequency and do it in this way. So probably you would have got some intuition, or you would have got some idea of like in what way we approach the problem. Now understanding what we have to do is very simple. The intuition part was a bit difficult on how to develop such intuition. So all we have to do now is just iterate these, like, it's up to you. If you want, you can iterate from left to right and store the strings inside the map, or iterate from right to left and store the subs, like prefixes and suffixes inside the map. So basically, if I see this thing, I know it has a prefix a coming up as the suffix as well, and aa is also coming up as both prefix and suffix. So I will just store it somewhere here. This thing is coming up as both prefix and suffix. Maybe you can, like the array we were talking about in which we will store, you can just store it there. And if you let us say if you had an array in which all the prefixes and suffixes which are equal for some strings were being stored inside this, like maybe let me take up a simple example. If there is a string like AA and a string like ABA and ABAB, in that case I'm talking about an array like this one. From AA you have two strings A and AA, so you will have A and AA. From AB you will have a string A. A is coming as both prefix and suffix. AB is not coming up as both prefix and suffix, so it won't be there. But ABA is coming as both prefix and suffix. ABA is coming as both prefix and suffix in this given string. So you will add ABA, and in this string you are having AB as coming up as both prefix and suffix, and ABAB as coming as both prefix and suffix. So from this string we did, so from this array we did create this array. Now the problem has got a lot simpler. For this string you just want to find out how many times it is coming in this array. One of those times it would have come up because of this string itself, so we will uh, like AA came up in the give. Okay, so let me include one more element. Let me include A also. A is also there. So when you talk about this A, when you talk about this A, now your task is not really to check up for all the prefixes and suffixes for these strings. Instead, you will just check the number of times this string A is coming up in this array. One of those times it would have come up because A is a prefix and suffix of itself also. So you will not really count that part, but all the other occurrences, all the other occurrences should be counted, like it is coming up two number of times. So it would be coming up as a prefix and suffix of, actually there should be, yeah, two. Like this and this. These are the two strings in which it comes as a prefix and suffix. So I hope that it makes sense. You have just written the prefixes and suffixes inside a new array, so it would be easier for you to just, now you just have to check out how many times it is coming up as a prefix suffix. And um, you can just keep track of it in some variable answer, which was initially 0, now it became 2. And there is one catch, there is one thing you have to see. All the prefixes and suffixes which were derived from this A does not have any significance in this array now, because let us say if there was another A here coming up in this array, then in that case, for that A, it should not really count this occurrence, because you have to consider only these strings. For like this I, the J should belong to any one of the strings on the right hand side, है ना? So for that, either you can delete it, or the other thing I did is I went from right to left and I just uh, calculate, like just started to store these prefixes and suffixes one by one in some map, for so that in the map it would be easier for me to find out the frequency in log n time. And uh, I'm just finding the answer. So if you are coming from right to left and you are at this A, it will have only these elements. It would not have these elements right now inside the cell. Right. So you will not have any wrong answers. Now I believe that the answer is, like, the problem is very doable. It is doable. You might have to spend some more time on your own though. Okay, so I'm using a string hash function which I copied from somewhere in the last contest. I just copied it once again from my previous solution. uh, you would have already studied about string hashing. If you have not, then obviously you should not really attempt this problem right now. First of all, try out some different problem on string hashing, some standard problems. After that, when you come here, um, here I am creating a count, a map which will store count, which will store the count of pair of long long. So as we know, Inside the map you would be storing the hash values, and the string hash which we have been using, like which the one which I use, actually has a pair, like is using double hashing. You would have also studied about double hashing also. In case if you have not studied about double hashing, then please search about it. So what we are doing here is, just instead of one hash value for every string, we are finding two hash values with different values of m1, m2, and the quotient with which we multiply. So the point here is that the chances of two different strings having a same hash is less, but just in case if two different strings get the same hash value, then you might get some wrong answer. So to avoid that, we are having two hash values. If both these hash values are same, in that only in that case uh, fun- the two strings would be considered equal. So we are going on from right to left. For every string, I'm finding the string hash. With the help of that string hash object I've created, I'm finding the hash value. I'm finding the hash value for the complete string. And then I'm saying, yeah, in case if this string hash, like this hash value is present inside the set, inside the map, inside the map which I've created, then please increment, like all those times whenever this hash would have come up from any of the strings on the RHS. For all of those strings, this current string can form a pair. Now, like it is something which we discussed in logic. So you just have to increment your answer that many times. After that, I'm having a for loop where this j is the length of the suffix I want to talk, or the prefix I want to talk about. So I'm taking a prefix of length 1, 2, 3, and so on till m, where m is the length of the current string, and I'm finding the prefix hash value and suffix hash value. If both of these hashes are equal, only then I am incrementing the hash value inside the map, and at the end I'm returning answer. Probably this is doable, and I hope that the session helped you out. So thank you for watching the video, and bye bye.